how do we actually complete the squares? Now, the first step is we pair off the terms with non-zero coefficients of x. So those would be the x squared term and the x term. So we pair those two off. So here we have 2x squared plus 4x, and of course the 3 is on the outside. That's the first step. The second step, we factorize out the coefficient of x squared, right? So the coefficient of x squared here is clearly 2. We factorize that out of the bracket. And so that will leave us with 2 into x squared, because 2x squared divided by the 2 is x squared. And then because we would have factorized out the 2, now we have to ask what is 4x divided by 2. And that will give us 2x, right? So 2x, and we close our bracket and we put our 3. The next step is arguably the most complex out of all of them, but it's pretty straightforward. We simply ask, hey, look at the coefficient of x this time, not x squared, right? In this case, we have 2. And we're going to ask, hey, what is half of this? What is half of 2? Right? And we add that half value to the bracket squared. And, well, I'll explain the rest later, right? Just now. So for now, just keep track in mind that the coefficient of x is 2 and half of 2 is 1. So we should be adding that to the bracket, right? We add half the coefficient of x all squared to the bracket. So x squared plus 2x plus the 1 squared. So plus 1 squared to the bracket. And of course, we have our plus 3. But we're not finished with this step. That's what makes it a bit more complicated compared to the others. In this step, because we technically would have added 2 times 1 squared to the bracket, it's not fair to have an equation, for example, a is equal to b, and just simply add, like, for example, 1 to one side of the equation, right? You can't just simply add 1. That will change the overall value as represented by that equation. So either we can add 1 to both sides, or we can consider adding 1 and subtracting 1, right? That will still leave a being equal to b. And so in completing the squares, we do something similar, whereby we add something, but we also need to subtract it to maintain the value of the line. And so we technically added 1 by 2 squared, 2 by 1 squared to the bracket. And so we need to subtract 2 by 1 squared from the outside, right? To make it even now, balanced out. And so the next step is we take this bracket and we condense it. We factorize by the perfect square factorization. And so we write 2 into, we take this x, we take this sign, and we take the 1. And so we have x plus 1 all squared. And then we just have to break down the outside terms, and that will be it for completing the squares. And so we have plus 3. Now we have minus 2 times 1 squared. 1 squared is 1. Negative 2 by 1 is negative 2. So we can write minus 2. And we basically finish, right? This will give us 2 into x plus 1 all squared. And plus 3 minus 2, you just have a plus 1. So this here, we can clearly see this is in the form a into x plus h all squared plus k. And we know technically if we take this one, which is our h, and we negate it and place it beside this 1, which is our k, well, we don't need to do anything to k. We have negative 1, 1, which is technically the coordinate of our turning point for this curve, 2x squared plus 4x plus 3. All right, a bit confusing at first when you do it, but once you go back through the steps and get a lot of practice, it becomes very easy. So first we pair off the terms in x, and then we factorize out the coefficient of x squared. Then we, a bit of a mouthful, add half of the coefficient of x squared, which is the coefficient of x here is 2, right? So half of it is 1. We add 1 squared to the bracket. Because we added 1 squared to the bracket, we need to subtract, well, technically by adding 1 squared to this bracket, we added 2 times the 1 squared to the overall line. And so we need to subtract 2 by 1 squared again. All right, and then the next line, we do our perfect square factorization to the bracket, in which case we use the x. We use this sign in front of the coefficient of x, and we use the 1. And so we have 2 into x plus 1 all squared, plus now we break down the outside. And that is the basic process of computing the squares.